velocity, under one is the phase velocity. We will calculate troop velocity as well as phase velocity. What is given in the introduction? In the introduction, cutoff wavelength and cutoff frequency. These two are depends upon what? Separation between the walls of the waveguide. Means how much gap is there between the two separations. From starting point to ending point is depends upon the separation between the walls of the waveguide. So because of that, the cutoff wavelength as well as cutoff frequency, both are the important parameters. Next, we will see what is how to calculate cutoff wavelength. To calculate cutoff wavelength, let A is the distance between the two walls. Suppose I have one wall here and open side. Another one is closed side. The distance between this is what? A. A is the distance between this one. This one, I am writing A as a one integer m with half of the wavelength. Here, what is the wavelength represented? Wavelength is represented with lambda n. Here, wavelength is represented with lambda n. So, here A equal to integer times of wavelength, which we are writing the value of A. After writing the value of A, I am calculating here the few more parameters based on this. What is lambda n here? Lambda n is wavelength of the wavelength which is normal to the direction of the plane. Lambda n is wavelength in the direction of the wavelength is normal to the direction of the plane. What is m? M is an integer. From the previous, we discussed the formula of wavelength normal to the plane formula. Lambda n equal to lambda naught of cos theta. Now this lambda n I am substituting in 2.1 equation. What is a 2.1 equation we have? A equal to m times of lambda n by n. If I substitute, what I will get? I will get the value of A. After getting the value of A, just I'm sending cos theta to the LHS and writing the equation for which one? Cos theta equation is written. So in this, what we did first, I took A. And we know lambda n value. Lambda n value is substituted. From that, we brought one term. What is that term? Cos theta term. Next, we have lambda n is normal to the plane. Wavelength for the normal to the plane. Next, one more we have lambda p for the propagation wavelength. What is lambda p? We will call propagation wavelength. This propagation wavelength formula is lambda naught by sin theta. What is the difference between lambda n and lambda p formula? Lambda n, there we took lambda naught by cos theta. Here we are taking lambda naught by sin theta. This sin theta I am writing as converting in terms of cos. How to convert in terms of cos? Under root of 1 minus cos square theta. And previously we got cos value. That cos value is substituted here. So which value we got? We got lambda of p. We got the equation lambda p. This lambda p, what I am doing, next to write the lambda p value, only denominator is equivalent to 0. Make denominator equal to 0. If denominator is making equivalent to 0, I am taking 1 equal m lambda c by 2a equal to 1. From this, what I am calculating? I am calculating the value of lambda c, cutoff wavelength. Here I have used three terms. Lambda n is wavelength across the normal to the plane. Lambda t is wavelength across the propagation. I am using another term, lambda c. What is lambda c? Wavelength across cutoff wavelength. Okay, cutoff wavelength. So here I calculated cutoff wavelength lambda c. From this cross multiply, what we will get? We will get the value of lambda c. After cross multiplication, we will get the value of lambda c. Where lambda c is the cutoff wavelength. What is A? Separation between the two walls. A is the separation between the two walls. In general, we know V equal to n lambda formula. Is it? V equal to n lambda. V is the velocity, n is the frequency, lambda is the wavelength. From this, I am writing n value. What is the value of n? V by lambda. Here, n is representing with frequency. N is represented with what? Frequency. F equal to V by lambda. This one I am substituting in the next one. As we know lambda value, what is lambda value from 2.4 equation? Lambda equal to 2a by m. 1 by lambda means reciprocal. M by 2a. That one I am substituting in the frequency equation. Then what we will get frequency? Fc reverse. Fc equal to m times of velocity times of 2a. This is the equation for which one? Frequency calculation we did. So finally, what is our title? Calculation of the wavelength, calculation of the frequency. So frequency calculation is over. Now next what we have to see? Wavelength calculation. Come to the wavelength calculation from equation 2.3 or 1. What is equation 2.3 in our textbook? Lambda p equal to lambda naught by under root of 1 minus m by 2 m lambda naught by 2a whole square. Now what did making lambda separate and m by 2a is writing as a single term. What is m by 2a from 2.4? 1 by lambda c. Lambda c equal to 2a by m. 1 by lambda ante reverse m by 2a. That is substituted. So we are getting equation only in terms of lambdas. So cutoff wavelength is calculated. So from the next equation, what we are getting from this? Frequency calculation is over. Propagation wavelength calculation. Afterwards, what did? Lambda naught by under root of just lambda naught is brought inside. Lambda naught by lambda c whole square. So we got propagation wavelength lambda p. And we have one relation. What is that relation? 1 by lambda p square equal to 1 by lambda c square plus lambda naught. This equation is known as guide equation. Explain about guide equation. From where to where you will cover? Guide equation, what are the factors has to calculate? First calculation is A. A is the separation between the two. Normal to the plate lambda n we have to calculate and calculate cos theta and calculate lambda p. You will get one equation of lambda p. From that calculate frequency value. After calculating frequency value, we have to calculate propagation wavelength. Next relation between lambda p, lambda c and lambda naught. If we write, what we will get? We will get the equation of guided equation. Waveguide equation we will get. Next topic what we have in this unit 2. We can expect this as a important question. Previous year short answer question. This is from the first unit. Group and phase velocities in waveguide. We have one formula Vg. What is Vg means? Vg is group velocity. Vp is phase velocity. Here I am writing Vg equation. Next I am writing Vp equation. Multiply these two equations. What is Vg? What is Vg? Vc sin theta. What is Vp? Vc by sin theta. Just observe the difference. There it is product, here it is division. Vg equal to Vc sin theta, Vp equal to Vc by sin theta. Multiply these two. What you will get? Sin theta is cancelled. We will get Vc square. After getting Vc square, V equal to n lambda formula. What is our formula? V equal to n lambda. This n is represented with here frequency. What is lambda p which we got from previous equation? Propagation wavelength formula. What is lambda p formula? Lambda naught by under root of lambda naught by lambda c whole square. Equation 2.6, previous topic. Substitute that one here. We are calculating phase velocity. What we are calculating? Phase velocity. This f times of lambda naught. F times of lambda naught is writing as what? Vc. velocity of light. Vc is velocity of light. Three terms we are discussing here. What are the three terms? Velocity, group velocity. One more is phase velocity. Another way is velocity of light Vc. Velocity of light Vc. That one is substituted. So we got final equation is in which one? Phase velocity equation. Phase velocity equation. Phase velocity Vp equal to Vc by under root of lambda naught by lambda c whole square. Next, what we have to do? Next, next task is calculating group velocity. Substitute this one in 1.13. Actually, in the textbook, somewhat equation numbers is up and down, means not mentioned properly. Now, where we have to substitute this one? 2.8. Just observe 2.8. Some mistakes, printing mistakes. From 2.8, what is Vg? Vc square by Vp. So, instead of 1.14 and 1.3, here you write from equation 2.8. This is the formula. Previously, we got Vp. Previously, we got Vp. Substitute that one, but it is in denominator. So, the term is reverse. Reciprocal of the term. So, we got what? We got group velocity Vg. Is this clear? So, two velocities is calculated. What are the two velocities? Group velocity and phase velocity. Just we will recall that once again what we discussed. First, how to start this answer? Total here three velocities we are using in this derivation. Group velocity Vg, phase velocity Vp, velocity of light is Vc. First write the equation of Vg. Next to write the equation of Vp. Multiply those two. We will get Vc square. Vg into Vp equal to Vc square. So we have to calculate first Vp separately, then calculate Vg separately. To calculate Vp first, what we have to write Vp equal to F times of lambda p. Substitute the lambda p which we got from the previous topic. And after simplification, we will get Vp. Now what you have to do? Substitute this Vp in 2.8. From 2.8, what is Vg? Vg equal to Vc square by Vp. After substituting, we will get the group velocity. So practice this one. Almost many times it is repeated. 5 marks essay question from the first unit. Next, now we will see 10 marks question from this one. Rectangular waveguides. Just see the short answer questions what are covered from this unit 2. Derive expression for Vp and Vg. Just now we saw. One more question is what is the relation between lambda p, lambda c, lambda naught? Where it is? That is waveguide equation. Waveguide equation. Next. Derive expression for lambda c, fc, lambda p. Same derivation, but question is different. Define phase velocity and group velocity. Define phase velocity and define what is cutoff wavelength. That is given in the introduction. Define cutoff wavelength and cutoff frequency. That is given in the introductory part. Next, we will see which one. 10 marks question from this unit. What are the 10 marks question? You will get either rectangular waveguide or circular wave. This is the index. This is the index. Rectangular waveguide. What are the things we have in rectangular waveguide? First, general derivation part. Afterwards, derivation, we have to go for TM mode. Which mode? TM mode. Next, after TM mode, we have to go to first TM mode. Next, TE mode. Next, TM mode, field pattern. Next, TE mode, field pattern. Field pattern of TE mode. Field pattern of TE mode. Next, what we have to do again? Circular waveguide. In circular gate, what we have? TM wave, TE wave. Next, field pattern of TM wave, field pattern of TE wave. These things we have to discuss in the this block 1. First, we'll start with rectangular waveguide. Here, rectangular. If the shape of the waveguide is in rectangular, we will call it as a rectangular wave. If the area of cross section is in circular, we will call it as a circular waveguide, which is given in the 3.2 first paragraph. What is rectangular waveguide? What is circular wave? If the area of cross section is in form of rectangle, it is called as rectangular waveguide. If it area of cross section is in form of circular, it is called as circular waveguide. Next, here I am concentrating only on circular waveguide with width as well as height. Here width is I am choosing as a A. A is taken as a width and B is taken as a height. A is taken as a width, B is taken as a height. Now we will see diagram. See, here what is this diagram? This is rectangular waveguide. Here we are taking along which direction? Z direction. And here width is represented with A, height is represented with B. In general, we know that electric field is always, what happens to electric field? Electric field is always perpendicular to the magnetic field. Electric field is perpendicular to the magnetic field. What it means? Electric field is across the surface, it is 0. Surface means this edges. Electric field in the middle is maximum. Across the surface is 0. Across the surface is 0. That is mentioned here. See, now at the surface of the conductor, the component of electric field is, which is parallel to the surface, is 0. Parallel to the surface is 0, which means electric field is perpendicular to the surface of the conductor. Parallel combination of this surface was 0. So which combination we have to concentrate? Perpendicular combination we have to concentrate. Here in a rectangular waveguide, I am taking two conditions. What is the two conditions? Electric field is 0 across the tangential. Electric field is 0 across the tangential and magnetic field is 0 across the normal. Across the now we have to simplify this electric field and magnetic field with the help of Maxwell's equations. That is given in the next paragraph. What is mentioned here? Maxwell equations are used to solve this electric field and magnetic, to determine electric field and magnetic field. Which one we are using? We are using Maxwell's equations. And now we will come to the and it is, we are concentrating here along Z direction. Is it? Which direction we are taking? Along Z direction. Along Z direction. Here I am concentrating the direction along e power minus gamma Z. E power minus gamma Z. Where I am concentrating, what is gamma value? Gamma value equal to alpha plus J beta. Alpha plus J beta is taking. Based on this, we will do derivation part. What is the first Maxwell equation? Here, first Maxwell equation is del cross H equal to dou D by dou T plus J. In this, I am keeping J as 0. J as 0. After keeping J as 0, what we will get equation? Del cross H equal to del cross H, what we will get? Dou D by dou T. Dou D by dou T. In this, in place of D, I am substituting, in place of dou by dou T, I am substituting something. In place of dou by dou T, I am substituting J omega. In place of dou by dou T, what I am substituting? J omega. In place of D, in place of D, epsilon E is substituted. Then what we will get answer, which is in the next page? Del cross H equal to 2. In place of dou by dou T, what I am substituting? J times of omega. In place of capital D, I'm substituting epsilon electric field E. Epsilon with electric field E. So this is the equation of del cross H. Is this clear, del cross H? Next come to del cross E. We saw across magnetic field. Now we will see electric field. Del cross E. What is another curl equation? Maxwell del cross E equal to minus dou B by dou T. Here again you take dou by dou T as J omega. What is d by dou T? Dou by dou T is taking as a J omega and B is taking as mu of H. Substitute these two in the equation. What we will get? Del cross is already we have minus sign. Huh? Already we have minus. So we will get equation 3.3. Which equation we will get, ma? Equation 3.3. Still now what we did? We calculated del cross E value, del H value. Using this, we had to do a big process, which in the textbook it is given directly. See the three, what are the next three equations? Now our task is simplifying equation number 3.4. But in the textbook it is given directly. Now we will see that one step by step. Derivation part. See here. Del cross H. Just keep your textbook beside. What is equation 3.2? Del cross H. Del cross H. That del cross H I am writing as a matrix multiplication. In terms of IJK. In terms of IJK, dou by dou X, dou by dou Y, dou by dou Z. Next, HX, HY, I can take. IJK, I am writing this one is del cross H. Which one I am writing, ma? Del cross H ki rasnan. Del cross H is represented as IJK, dou by dou X, dou by dou Y, dou by dou Z, HX, HY, HZ. Matrix multiplication. How we will do? I. You remember matrix multiplication? I time I. How you will write? Dou by these two terms. Dou by dou y times of HZ minus and of HY. Is this okay? Next to J term. Minus J we have to take. Cross multiply I and K values. Minus dou by dou Z of HX. 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 Next K term, close this one. Next I terms of dou by dou X of HY minus dou by dou Y of HX. This is LHS side is okay. Just observe 3.2 in the textbook. What you have? J omega epsilon is there, na? We wrote LHS part. From 3.2 we wrote LHS part. What is the RHS part we have? J omega epsilon E. E is written as EX of I, EY of J, EZ of K. Splitting E term. Which term we are splitting? E term. E term is written as EX, EY, EZ. Is this so clear? Come to the next one. In place of dou by dou Z, I am substituting minus R. And cross-check the equation. Is it satisfied after substituting? This is not gamma actually. It is gamma. Just refer the textbook after 3.3. Expressing the above curl equation in terms of XYZ. putting dou by dou z is equal to minus gamma. Putting dou by dou z equal to minus gamma. Just observe in which place I am keeping dou by dou z. Check, substitute in the first equation, I is written as it is. Dou h z by dou y is written as it is. In terms of dou by dou z, what I have to keep? Minus gamma. Minus of minus plus. Minus of minus is plus gamma hy. First term we got. Next check second term. Minus j dou hz by dou x written as it is because we are substituting only dou by dou z term. Check the second term. Minus of minus plus gamma hx. This is gamma hx. Next check is any changes in the third term? No, because there is no dou by dou z. Again RHS is written as it is. What is RHS? J omega epsilon types of EXI, EYJ, EZK. Now what I am doing, I am comparing ith term. LHS side, RHS side. Again compare jth term. Next compare kth term and form 3 equations, which is given in the textbook directly. Just see in the textbook 3.4. 3.4. Check, compare only I equations. LHS lay on the ith term. Dou hz by dou y plus gamma times of hy equal to j omega epsilon times of ex. Understood? Compare jth term. For the whole term, we have minus symbol. Minus of dou hz by dou x minus of gamma hx. Gamma hx equal to j omega epsilon ey. That is second term. Next third term, dou hy by dou x minus dou hx by dou y equal to j omega epsilon times of ez. So we got 3 equations. For which one we got? Del cross H. These 3 equations is related to which one more? Del cross H. Now next task, what we have to do? For which one we have to do next? Del cross E. Del cross E. Now how you will split del cross E? Del cross E, how we will do, ma? Same I, J, K, dou by dou x, dou by dou y, dou by dou z. In terms of hx, hy, hz, what you have to write? Ex, ey, ez. In RHS, what you will get? Minus j omega mu. In place of h, what you have to write? Hx, hy, hz. Again, you have to do matrix determinant form and equate LHS and RHS. You will get 3 equations. What are the 3 equations? Which is equation number 3.5 in the test book. We will see the derivation. The next slide, derivation. Just go through this derivation. What is del cross E LHS side? I, J, K. Dou by dou x, dou by dou y, dou by dou z. Ex, ey, ez. Again, I times of dou by dou ez by dou y minus terms miss I will show in another PPT. Del cross H is completed, is it? Del cross E. Check del cross E from this. Zoom this one. Zoom this. Check I, J, K. Dou by dou x, dou by dou y, dou by dou z. Ex, ey, ez. I time of cross multiplication. J times, K times, we got. RHS what we have? Minus j omega mu times of hx, hy, hz. And what we have to do? Substitute dou by dou z equal to minus gamma. That is not R, minus gamma. Then we will get one equation. Next, what we have to do? Compare the coefficients of I, J, K. After getting comparison, we will get the equation. Why we are getting minus means in del cross C, we have minus of J omega mu. Check equation 3.3. In 3.3 for J omega we have minus sign. For that, the next three equations, whatever we are getting is minus. First term, second, third one. First term. We will cross check. Is if any mistake, we'll check. And what is the first term? Dou Z by dou Y. What is d by dz? We have to substitute gamma. Minus gamma. Minus of minus, it is plus. In notes, it is correct only. What is given here? Plus only given, no? This one. Not for... Show me which one you are saying. In the notes also, it is minus gamma only. Equation number 11, just check. Equation number 11, 12, 13. 11, 12, 13. 11, 12, 13 equations is related to del cross E. Previous equation, whatever we did is del cross H. So, exam, you have to simplify and write. Don't write directly. If you write directly, it is difficult to remember. Simplification process only, easy to write. Afterward, what is mentioned again in the textbook? See? Very long. All mathematical part. First unit is completely mathematical part. Next, write two wave equations. The next two wave equations is 3.6 and 3.7. Up to 3.4 is over. Simplification. For these three is for simplification of which one? Magnetic field. The next three equations is for simplification of electric field. Simplification of electric field is over. Simplification of magnetic field is over. Next, what we have to do? Take two wave equations. What are the two wave equations? Del square E, del square E. No, this is a mistake. Wait. See here. What is del square E equation? Mu epsilon dou square E by dou t square. In place of dou square by dou t square, substitute minus omega square. In place of dou square by dou t square, what we have to substitute? Minus omega square. So what you will get equation? Del square E equal to minus omega square mu epsilon E. Same way now, which one we have to write? We wrote for del square E. Next we have to write for del square H. Next del square H equation cheppandi. Del square H mu epsilon dou square H by dou t square. In place of dou square by dou t square, what you have to substitute? Minus omega square. So what we will get? Del square H equal to minus omega square mu epsilon H. Up to here is completed. And next we are writing two wave equations again in the propagation of two wave equations. What are the two wave equations we have? See, previous del square is in the 3.6 you observe equation 3.6. 3.6 LHS part I am writing in terms of dou square by dou x square. Delta square E in the delta square E is replaced with x component, y component, z component. 3.8 ఎట్లా వచ్చింది? From 3.6. ఎక్కడి నుంచి వచ్చిందమ్మా 3.8? From 3.6 నుంచి వచ్చింది. 3.9 ఎక్కడి నుంచి వచ్చింది? 2.7. From 3.7. From 3.7. Two wave equations are writing using del square E and del square H. And del square E equal to what is writing here? Dou square by dou x square. Dou square by dou x square of Ez, dou square by dou y square of Ez, gamma square of Ez, x component, LHS component. And YHS component is minus omega square epsilon E, Ez. Same way H1 is also written. Same way H1 is also written. See here. Next, what we have to do? Substitute the value of H5 from 3.5 into EX of equation 3.4. So up to here, one field, leave up to here. And next, come to 3.4 and 3.5. ఉన్నాయా 3.4 3.5 లో 3.5 లో మనకు సెకండ్ ఈక్వేషన్ ఉంది చూడండి. వాట్ ఇస్ సెకండ్ ఈక్వేషన్? minus the dou z by dou x minus gamma equal to minus j omega mu times of hy. From this, take hy. That one, you have to substitute in 3.4 first one. Getting my point, what I am saying? I will show again the derivation part because here everything is given directly. Equation. I will show this in the notes part. See here, 3.5 second equation. What is 3.5 second equation? 3.5 lo second equation enti? Minus dou E by dou Z. Minus dou Z by dou X minus gamma times of EX minus j omega mu hy. All minuses are cancelled. You will get complete equation in terms of plus. From that, what you have to do? J omega mu. Just check the screen. J omega mu, which is in RHS side, shifting that one to LHS side and writing the equation only in terms of hy. My final intention is what? I have to calculate hy. hy kanukovali. Equation hy etla kanukuntamamma? Send j omega mu of RHS to other side. You got hy. Now this hy, where you have to substitute?
In the 3.5.
3.4 lo first one. Text book lo chudandi. 3.4 lo first one emundi? Dou by dou y of hz plus gamma times of hy. ఈ hy ని తెచ్చి ఎక్కడ పెట్టాలి? ఫస్ట్ లో పెట్టండి. పెట్టి సింప్లిఫై చేస్తే what we will get? We will get ex, ey, hx, hy. And now you check how to simplify.
దీన్ని తీసుకెళ్ళి ఎక్కడ పెట్టాను?
hy ఇక్కడ క్యాలిక్యులేట్ చేసాం కదా hy. దీన్ని తీసుకొచ్చి ఇక్కడ కాదు దీన్ని తీసుకొచ్చి ఈడ పెట్టాలి. Substitute hy in 3.4 లో substitute చేయాలి. Check the derivation part. Four వస్తాయి. ex, ey, hx, hy. Now we will see substitution part. This is lengthy talk. First unit. Again we will see overview what we discussed. చెప్పండమ్మా. hy వచ్చిందా? Where we have to substitute this hy? Dou by dou y of hz. Dou by dou y of hz plus gamma times of hy equal to j omega epsilon ex. See here, the substitution part. First term is written as it is. Next gamma is written as it is. In place of hy, I substituted 1 by j omega mu dou z by dou x plus gamma times of ex equal to RHS is same. After what, next student ఏం చేస్తున్నాం? Internal multiplication. First step is as it is. Dou hz by dou y is as it is. What is next step? Plus gamma by j omega mu times of dou z by dou x. Second term వచ్చింది. Next gamma into gamma ఏమొస్తుంది? Gamma square ex by j omega mu equal to j omega epsilon ex రాసాం. నెక్స్ట్ స్టెప్ ఏం చేస్తున్నారు? Third term is sending to RHS side and making EX common. See here, first term is as it is. Second term is as it is. What is third term? Gamma square j omega mu EX. That one is shifted to RHS side. After shifting RHS side, what we are making common? EX is made common. What is the next step? Next step. Finally, our intention is we have to calculate EX. Derivation నుంచి ఏం calculate చేయాలి మనం? EX. EX. చెప్పండి, నెక్స్ట్ స్టెప్ చెప్పండి. First step as it is. Second step as it is. What is did in the RHS side? LCM. EX is common as same as previous. ఇది LCM చేసి ఒక టర్మ్ ఫ్రేమ్ చేసారు. And made minus common. In లోపల ఏముంటుంది inside? Gamma square plus omega square mu epsilon. That term is treated as a one constant. That term is treated as what? Constant. What is that constant? That constant is called as Kc square. Now, I'm keeping EX, remaining terms is shifted to other side. Final equation we got. We got final equation. And now we tell what we did from the beginning. Next, I will proceed. Because if you understand this, then only you will understand next. Now you tell what we did from the beginning. Derivation part. One by one. First, del cross H. J, 0. What is dou by dou T? What is D? E. And we framed one equation. After framing, what we did? Del cross H, I, J, K, dou by dou X, dou by dou Y, dou by dou Z, HX, HY, HZ, matrix format. Simplified. RHS side ఏం చేసాం? J omega epsilon రాసి, E నేమ్ రాసాం, EX, EY, EZ. రాస్తే మనకి ఏమొచ్చాయి ఈక్వేషన్స్? 3 equations we got. Comparing ith term, comparing jth term, comparing kth term. What we will got? We got equation 3.4. Next ఏం చేసాం? Del cross E equal to minus dou B by dou T. In place of dou by dou T, minus j omega. Here plus j omega. There it is minus j omega. In place of H, what we substituted? In place of B, we substituted mu H. Mu H substituted, sir. Again, del cross E is writing I, J, K, dou by dou T, dou by dou X, dou by dou Y, dou by dou Z, HX, HY, HZ. Again, comparing ith term, jth term, kth term. Which equations we got? We got 3.5. 3.5. Next thing is, we are writing two wave equations. Again, after writing two wave equations, splitting in terms of dou by dou X, dou by dou Y, dou by Z, which is equation number 3.8, 3.9. Split jesa. After what, again, what we did? 3.5 lo second equation.
HY value తీసుకెళ్ళి EX లో
3.5 second equation.
H value
3.5
which equation?
second equation. HY value
Substituted 3.4.
Substituted in 3.4
second term of the H plus.
in equation 1 in place of HY. what we will get? We will get EX, we will get EX. We will get EX. Based on that, we have to write EY, HX, HY, which are equation number 3.10, 11, 12, 13, 14 ఉన్నాయి చూడండి. Na test work. How to remember for the exam point of view from these equations? EX is denominator dou by dou x ని చూడండి. EX కి denominator లో ఏముంది? Dou y, dou x. EY కి dou x, dou y ఉంది. First two terms plus, next two terms minus. 3.10, 3.12. Observe. Observe 3.10, 3.12. ఏంటమ్మా difference? Signs change. So if you derive EX based on that, remaining equations has to write. Now what are the remaining equation here? EX we calculated EY. Next we calculated HX. Next we calculated HZ. These are the four equations. Very, very, very important. HX, HY వరకు calculate చేయాలి. These equations is known as what? Field equations. Just check backside the question how it is asking. That is comes. Who want to attempt question from the first unit? You have to practice this derivation. Third question చూడండి. Derive field equations in rectangular waveguide. Rectangular waveguide field equation derivation is up to here. And next, we have to calculate wavelengths continuation. After calculating EX, EY, HX, HY, in the derivation part, we used one term constant, Kc. What is Kc square we got? Kc square equal to? Kc square equal to gamma square plus omega square times of mu epsilon. From this, I am writing gamma value. How to write gamma value? Gamma square equal to, terms is shifted. K square minus omega square mu epsilon. From this, write gamma value. Gamma equal to under root వస్తుంది. Gamma we will get under root. And also calculating frequency, cutoff length, cutoff frequency, cutoff wavelength. Frequency term we will see. What is frequency formula? Omega equal to 2 pi f. In place of f, this is also equal to Kc by root mu e. This is also equal to Kc by mu root mu e. What is omega c? 2 pi fc. This is also equal to Kc by root mu epsilon. Kc root mu epsilon is taking as a V0, which is also the same sentence in the test book. Kc times of V0. From this calculated lambda value. What is lambda formula? V0 by Fc. What is Fc? Previous we got Kc by root mu e. Kc by root mu e. V0 by Fc also can be write as 2 pi mu naught by Fc rasar 2 pi by Kc. Yeah. See what is lambda formula? Actually, we know V equal to n lambda. Is it? V equal to n lambda. Lambda equal to V by n. This is also can be equated to 2 pi by Kc. What is Kc formula? Omega c under root of mu epsilon, which we got from the previous. Check Kc formula. Cross multiplication. Kc equal to omega c times of under root of mu epsilon. That is substituted. This is called as cutoff wavelength. So To each topic, we have to calculate cutoff wavelength as well as cutoff frequency. Just go through the topic once. After calculation, what we have to say that we have rectangular wave boundary conditions. What are the rectangular wave boundary conditions has to maintain? E tangential equal to 0. When E tangential is 0, when y values is lies between 0 to b. When y values lies between 0 to b, at that time E tangential is 0. Again, E tangential is 0. When it is 0, when x is equal to 0 to a. These are the boundary conditions. And these can be discussed in terms of transfer magnetic wave, TM mode, another one is TE mode. Next, we will discuss what is TE mode, TM mode. Before going to this, for the 2 minutes, just go through the what we discussed. Because if you understood the first one only, you will understand the next one. If anyone understood, you can just discuss the points. Anyone who will tell? Will you tell? First answer. What we discussed in the first answer. What we discussed in the first year. You start from
Yes.
here.
Del cross H and del cross E. We have to calculate these two. Del cross H and del cross E.
For that, what is the procedure has to follow?
Here del cross H is dou by dou T of D plus J. This is del cross H. From this, here J is 0. Then del cross H is dou D by dou D by dou T.
Good.
Here dou by dou T is J omega.
Omega. And
Here we
substitute D.
substitute D also as epsilon E. So we substitute these
For
both.
these two.
We get del H. Del H is J omega epsilon E. Another third equation.
Two
is
equations we have,
yes.
curl equations. One is del cross C,
And
another.
Here del E is equal to minus J omega mu H. Because here B is mu H. Mu H. Also we have dou by dou T is
equal to J
omega. So from these expressions,
after substituting, we got
we
del
got,
cross C.
del cross
Del
E
cross,
is minus J omega H mu naught.
Then how we are getting 3.4 and 3.5 on what basis?
Going with all this from matrix method.
Multiplication. In place of del cross C, what we are writing? IJK, dou by dou X, dou by dou Y, dou by Z.
Yes.
EX, EY, EZ. All these are LHS terms.
Yes.
RHS terms, what we are writing? J omega mu, HX, HY, HZ. Next, doing matrix
Doing matrix method.
multiplication vector form and equating ith term, jth term, kth term.
Yes,
We will get which equation? Equations 3.4.
yes, ma'am. Dou Hz by dou Y plus gamma Hy is equal to J omega epsilon Ex. And another one is minus dou by dou X of Hz minus gamma Hx is equal to J omega epsilon Ey. Another one is dou by dou X of Hy minus dou by dou Y of Hx is equal to J omega epsilon Ez. Similarly, we have to continue the process for del cross E also.
Same method.
Same method, matrix method. After that, we get another three equations in terms of Ex and Ey. Ex, Ey, and Ez. That is, those are dou by dou Y of Ez plus gamma Ey is equal to minus J omega mu times of Hx. And another one is minus dou Ez by dou X minus gamma Ex is equal to minus j omega mu times of Hy. And another one is dou by dou x of Ey minus dou by dou y of Ex is equal to minus j omega mu Hz. Here we can get, we can observe that all the equations are in
Minus,
negative.
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 Why we are
The
getting
we get-
negative? Because del cross equal minus sign
minus,
we
yeah,
have. For that
yes,
we are
yes.
getting this one in the negative.
Yes.
Next, take two wave equations.
Yes. Yes.
After that, del continue. Del square E is equal to mu epsilon dou dou square by dou t square E. Dou square E is equal to minus omega square mu epsilon E. Here we know that dou square by dou t square is equal to minus omega square. Substitute this here now.
Okay.
Similarly, we can get here
Del
in
square
terms of
H.
H. Del square H is equal to mu epsilon dou square by dou t square H. After that, del square H is equal to minus omega square mu epsilon.
Why we are getting
H.
minus omega square?
Here dou square by dou t square is
minus
omega square.
This one is splitting and we are getting 3.8 and 3.9.
Yes, ma'am.
Next, after this, what we have to do? How you are getting these equations? Kx, Ex,
Yes.
Ey, Hx, Hy. How
Hy.
to simplify these four equations, please?
From 3.4 and 3.5
Five.
equations, we can
how?
get all of.
How? From
How?
3.5.
Here we have to substitute Hy
From where?
values.
From where?
3.4 second equations.
Where you from where you are getting Hy value?
3.5 second equation.
From
The-
3.5 second equation,
Get
Hy we
Hy
have to
value.
find out.
We have to substitute this one into 3.4 first equation. After that, we can get all these things.
After simplification, we will get Ex,
Okay.
Ey, Hx, Hy.
And these are the field equations.
These
what
are
we
the
have to
field
get.
equations. Next, what we are doing, only constant term simplification. Based on that, we are calculating cutoff frequency. Next, we are calculating cutoff wavelength and writing boundary conditions. Boundary conditions up to here is rectangular. Rectangular, what we discussed? Rectangular waveguide is up to here.
Yes.
Again, we have two subheadings for this one. One is transfer magnetic waves, another one is transfer electric field. We will see transfer magnetic field now. In transfer magnetic field, see here, the major things here is in transfer magnetic field, we will treat Ez equal to 0. In transfer magnetic field, Ez equal to 0. Ex, Ey is also 0. Ez, these first 2-3 conditions we have to remember. What are the conditions we have? What are the condition? Ex, Ez equal to 0. Next, Ex, Ez equals 0. Where? At y equals 0 to b.
Lies between 0 to b. At
Next.
Ey is equal to 0. At x is lies between
0 to a.
0 to
Another condition is Hz is equal to 0.
And
Based on these conditions, in the previous topic, we have wave equation.
yes.
What is the equation
Dou
number?
square is-
3.8. From 3.8. Dou square by dou x square of Ez. Dou square by dou y square of Ez. Plus gamma square Ez. Equal to minus omega square mu epsilon Ez.
Yes.
You take that equation. In that equation is simplifying using variable and separable method. In mathematics, you have variable and separable method. So comparing your equation with one simple equation, which is in variable and separable format. What is that equation? E of xyz equal to Ez of xy e power minus gamma z. Okay, separation method. This one I will show here in the notes. A little bit simpler it is written. See here, how we wrote. We have equation, general equation. Dou square by dou x square of Ez, dou square by dou y square of Ez, plus gamma square of Ez equal to minus omega square mu epsilon Ez. Made Ez common, so we got kc square term, which we saw previously. The equation is in terms of kc square we got. After getting kc square, I'm treating this. What? Dou square by dou x square plus dou square by dou y square plus kc square equal to, I'm writing equation in terms of x and y. Okay, and writing one equation. What is that equation? Y times of x, x times of y. Equal to kc square of x and y. Y terms of x, x terms of y, plus kc square terms of x and y. And divide this equation both sides with x and y. How to divide this equation both sides x and y? Suppose here I have y divided by xy. What you will get? I have y here. Just see y. Took this x. One more term is y. Y is cancelled. So we will get x term. First term is x term. After division, we will get here y term. Next here x and y. Denominator divide with x and y. These two is cancelled and we will get only kc square. Yes. That is written here. Where it is written? 1 by x of dou square x by dou x square, 1 by y of dou square by dou y square plus kc square equal to 0. This one, again, what you have to do? Y term bring to RHS. X term and kc terms is keeping LHS. Y term bring RHS. From this, see the next one. Only LHS 1 by x dou square by dou x square plus kc square is treating as one constant ky square. Only LHS term. Which term?
1 by
LHS term. What is our LHS term? 1 by x dou square x by dou x square plus kc square is equal to one constant ky square. From this, kc square shift to other side. Ky square minus kc square was. Treat this as one of the new constant. Treat this as one of the new constant kx square. Now take second term. What is our second term? Minus 1 by y dou square y by dou y square equal to take another constant minus same constant. For the first term also I took minus ky square. For the second term also I took minus ky square. So based on this I will conclude that kc square equal to kx square plus ky square. After this, for the simplification purpose, I am using two x and y equations. Which equations? X equation and y equation. What is x? X equal to a1 cos kx, b1 sin kx. Y equal to c1 cos ky, d sin ky. Here what I am doing, I am treating both a term and c term as a 0. Which terms is 0? A term and C term is 0. So what you have B term and D term, multiply both X and Y. What you will get? B1, D1, sin KX, sin KY. Both is multiplying. This A term, C term is 0. Multiplying B term and D term. We will get B1, D1, sin KX, sin KY. That is written here. B1, D1, sin kx and sin kx. This B1, D1 is treating as a new constant A again. This B1, D1 is treating as a new constant A. New constant A. And sin kx term is there now. Yes. That one I am equating to 0. In place of x, I am substituting A. X equal to A. Emosundi sin Ka equal to 0. Or Ka equal to m pi and calculating K value. K value is what? M pi by A. Same way, calculate K by M pi by B also. We are calculating M pi by A and M pi by B. This one is substituting in the main equation. What is main equation? Ez. So cross check where is Ez?
Here in 3.8 now.
No. Here this A sin chi x plus B sin x. Ez equal to where I am substituting? I am substituting in previous one. We have one. See here. Ez equal to A of A sin kx sin ky. And cross check after substituting which equations you will get. You will get equation 3.26. In place of k, x, I am substituting m pi by a. In place of ky, I am substituting n pi by b. We are getting which equation? Equation number 3.26. Now, I am treating hz equal to 0. And just observe here, you have ex, ey, hx, hy అనే equations ఉన్నాయా? ఇవి ఎక్కడి నుంచి వచ్చాయి?
Last field.
Equations. Observe 3.10, 3.12, 3.13, 3.14. వెళ్ళండి బ్యాక్ వెళ్ళండి మళ్ళీ.
Second field equation.
అందులో నుంచి రాయాలి. 3.10 లో కీప్ hz టర్మ్ as 0. In 3.10 లో hz టర్మ్ అంటే ఫస్ట్ టర్మ్ అంతా 0 అయిపోతుంది. Which term is left? Gamma dou z by dou x.
Yes.
That is your ex here. Check.
Okay.
Keep hz equal to 0. Where you have to keep hz equal to 0 in which equation? Equation number 3.10. So your first term becomes 0. First term ఏమైతుంది? 0. You will get only second term. This is your second term. Understood?
Yes, ma'am.
3.10 లో hz ని 0 పెట్టాలి. Then we will get ex. After that, we know that what is gamma? Alpha plus j beta. What is gamma? Alpha plus j beta. And I am keeping alpha as 0 and substituting gamma as j beta. I will get this equation. Which equation? Ex. Get ex equation. If you get ex equation, similarly you have to write ey, hx, hy remaining equations. Ex first of all తీసుకురావాలి. Based on that, we have to write other equations. Ey, hx, hy.
All field equations.
All field equations you have to write. After that, see cutoff wavelength of TM mode. Today we will stop with TM mode up to field patterns. And now we see the cutoff wavelength of TM mode. What is cutoff wavelength of TM mode? Formula.
See.
What is kc square from the previous derivation? What is kc square? Gamma square, omega square, mu epsilon. From this I am writing gamma in LHS. What we will get? Kc square minus omega square, mu epsilon. From here, previous derivation. From this, what I am writing? Gamma square. From that, writing gamma square. After writing gamma square, equate to 0. This one. Kc square, omega square, mu epsilon, equate to 0. From this, what we have to calculate? Calculate the value of gamma. Calculate the value of omega. Calculate the value of wavelength. Previous already same method we did. Cutoff wavelength, cutoff frequency calculate చేసాం ఎక్కడ? Rectangular waveguide లో after calculating gamma value, page number 16 లో calculate చేశారు. Frequency calculated as well as wavelength calculated. Same way for this one also. Boundaries calculated. Same way also we have to calculate here frequency and wavelength. Then formulas are. Next, one more formula we have to write Kc formula. What is Kc formula? Kc square equal to, what is Kc square? Kx square plus ky square. What is Kx? M pi by a whole square. What is ky?
N pi by
b. Substituting those things and square remove చేస్తే square root వస్తుంది. We got Kc value. Kc value equal to M pi by a whole square plus N pi b whole square.
Lambda.
Substituted Kc in the lambda. What is lambda formula? Lambda is equal to 2 pi by KC. So reciprocal అయిపోతుంది.
Yes, ma'am.
So we will get which formula finally? We got the formula of lambda C.
Yes, ma'am.
After substitution, we
Cutoff
got the
wavelength.
formula. Cutoff wavelength is calculated. This is the final formula. Cutoff wavelength. Similarly, cutoff frequency is also calculated.
Yes, ma'am.
Next, see field patterns. What is the field pattern? Observe HX, HY equations.
Okay.
3.29, 3.30. 3.29, 3.30. HX, you have sine and cos terms. 3.29, 3.30. Which terms is there?
Here.
For HX, we have one sine term, one cos term. For 3.30 equation, HY is cos term, sine term. Based on this, I am writing field equations. Just compare these equations and those equations. HX is directly proportional to one sine term, one cos term. HY is directly proportional to
Cos term and sin
cos term and sub. So these two equations you write beside from where we are writing?
From this
3.29 from 3.30. These equations is comparing with 3.29 and 3.30. That is the field pattern of TM waves. And draw the diagram. End view and side view. How it looks in end side, how it looks sideways. Now you cross check EX, EY, EZ equations similarly. Previously we calculated EX, EY, EZ, HX, HY we calculated. EX, EY, EZ, what are the equation numbers you are comparing? 3.27 last code already. 3.27 you have to compare. You have to compare 3.28. Another one 26. From 3.26, which is two sine terms or sine cos or cos sine.
EZ is sin. EX is one cos and sin term. EY is one sin term and cos term. EZ is both are sin terms.
Compare the equations. This is called feed patterns. From 3.26, page number 19.
Yes, ma'am.
You are using RHS to sine terms of a sine cos or cos sine. 3.26.
One cos and one sin term.
From 3.26, I said.
Sorry, ma'am. That is EZ.
Two sine
Two
terms.
sin terms.
For EZ, we are using two sine
sine
terms.
terms.
Is it matched? Yes.
Yes.
Next, check with EX.
3.27 term. One
EX
cos
is
term and
one cos
sine
term and one sine
Sine
term. For EY,
EY one sin term and one
one
cos term.
cos. Okay. If you write here, up to, we will complete which one? Field pattern of TM1. Just we will recall once again what we discussed in this. What we discussed in this one? First is HZ equal to 0. First we have to write which one? Boundary conditions, right? First time write
Boundary conditions.
First write boundary conditions. After writing boundary conditions, take wave equation. This wave equation we are simplifying using variable and separable method. Sorry, just recalling. We simplify this one using variable and separable method. Variable and separable method, and bringing one x term, one y term, one constant term. After taking x term, y term, and constant term, what we are doing? Equating x term with kc square.
Yes.
X term and kc square is taking as one constant. Second term with kc square is another constant, and bringing what? Kc square equal to kx square plus ky square.
Yes.
Next, what I am doing? A simple sinusoidal wave equation I am taking in terms of x and y. X equal to a cos x plus b sin x, y equal to c cos x plus d sin. Here, a1, c1 term is 0. What we will get? Only b1, d1 term we will get, and multiply these two. b1, d1 is treated as one new constant a.
Yes, ma'am.
Here B1 D1 is treated as one new constant A,
Yes.
and just sin kx, this term is equivalent to 0, which is equal to m pi by A.
Yes.
Again, this term is equivalent to 0. And again calculating as n pi by B.
Yes.
Kx unte vasthundi m pi by A vasthundi. Ky ante n pi by B vasthundi. Again we have to substitute those in where A field ikkada undi kada. A sin kx sin ky unda 3.23. Ade values తీసుకొచ్చి 3.23 లో పెట్టాలి. After keeping in 3.23, which equation we got? 3.26 వస్తుంది. 3.26.
Is that is equal to, yes.
3.26 వచ్చింది. ఆ 3.26 వచ్చాక ఏం చేయాలి? ప్రీవియస్ 3.10, 11, 12, 13, 14 ఉంది కదా, అందులో మనం ఏం చేయాలి? HZ ని 0 పెట్టాలి. HZ ని 0 పెడితే మనకి EX వస్తుంది. బేస్డ్ ఆన్ దట్ వీ హ్యావ్ టు రైట్ రిమైనింగ్. EY రాయాలి, EZ రాయాలి, HX రాయాలి, HY రాయాలి. హౌఎవర్ HZ ఈక్వల్ టు 0. ఇప్పుడు ఈ ఈక్వేషన్స్ వచ్చినాక మనం ఎక్కడ కోరిలేట్ చేయాలమ్మా వాటిని? ఫీల్డ్ ప్యాటర్న్స్ లో కోరిలేట్ చేయాలి. సైన్ ఉందా, కాస్ ఉందా, కాస్ ఉందా, సైన్ ఉందా చూసుకోవాలి. సేమ్ వే కట్ ఆఫ్ లెవెన్స్, కట్ ఆఫ్ ఫ్రీక్వెన్సీ క్యాలిక్యులేట్. సేమ్ మెథడ్ లో నెక్స్ట్ వన్ కూడా ఉంటుంది, షార్ట్ ఫామ్ లో చెప్తాను ఇప్పుడు.
Yes.
ఇప్పుడు చూడండి, ఇందులో సేమ్ వేరియబుల్ సపరబుల్ ఇస్ రైటింగ్ యాజ్ ఇట్ ఈస్. ఫర్ దిస్ ఫస్ట్ we have to concentrate boundary conditions. What are the boundary conditions for this one?
HZ is lines between 0 and A. HZ is 0 here.
There
Which one?
we took EZ.
EZ. Yes.
Here we are writing HZ.
HZ.
Here we are writing HZ and written TE కేమో TH లో రాస్తున్నాం, H లో రాస్తున్నాం, TM కి TE లో రాస్తున్నాం.
Magnetic waves. Here
Electric waves are present. Again variable separable method లో ఈక్వేషన్ తీసుకున్నాము. There A and C is 0.
Yes.
Here B and D is 0. Same method almost. See here. 3.40 కింద చూడండి. Below the 3.40 equation. Here A, there which is 0?
B
AC is 0.
0.
We wrote B and D1. Here
B and D are 0.
0. We wrote A1 C1, which is writing as a new constant B.
B. Okay.
Again we are calculating m pi by A, n pi by B. That one is substituting where? In this 3.40. Again you will get equations, and now based on this, now we tell the field patterns, which is proportional. Cos-a, sin-a, sin-a, cos-a అనేది ఇది ఇక్కడ చెప్పండి. ఇప్పుడు చూసి EX చెప్పాలి, EY చెప్పాలి, HX చెప్పాలి, HY చెప్పాలి. From those, then we will start.
All the field equations. X is equal to, X is equal to, HY is equal to, Z is equal to 0.
For this also we have cutoff wavelength and cutoff frequency. Now we tell the field patterns of TE mode. First I will write in short form EX. EX చెప్పండి. Completely EX equal to 0. Complete EX equal to 0. Why we are taking EX equal to 0? Because here we are writing for TE10 mode. The TE10 mode. Check EY. From the equation, which equation we are writing EY? EY ఎక్కడ వచ్చింది మనకి? 3.43 చూడమ్మా. Check 3.43 equation.
Here.
Actually, we have EX also. EX is directly proportional to cos and sin. Afterwards, we will make why we are getting 0. We will see afterwards. EX is directly proportional to cos and sin. Now for EY, from equation 3.43, one sin.
Sin and cos.
Cos.
Sin and cos.
Next,
HX.
you tell HX.
Directly proportional to sin and
HX
cos.
is directly proportional to
Sin and cos.
sin and cos.
Then HY.
Next, HY.
Cos and
H
sin.
is directly proportional to
Cos and sin.
cos, one cos term, another sin term. And now you see here, is it matching? Field patterns of TE mode. EX is made 0 completely. Whatever we are getting, this EX is made to 0, which is page number 26, 3.49. What is these 4 equations is from where? Equation 3.49. Equation 3.49 and draw the diagram. The main difference is there we are keeping which term 0? AC is 0 na, BD 0 na, first danki.
AC is 0.
For this,
After that, BD is 0.
BD is 0.
And
That is
AC is the one constant.
only A.
A1, C1 is B.
B.
Constant. After that, B1, D1 is constant
So
A.
B. Okay.
Constant A.
After that, write field equations. Next, which is proportional? You cross check.
Yep.
Directly proportional, which is directly proportional. And draw the diagrams. Field distribution diagrams you have to draw. So just check the questions from backside, whatever we discussed today. Model questions. Today we discussed only rectangular waveguide, is it? Check question number 8. First, second number 8, what you have to write for this one? Derive the expression for the field components of rectangular waveguide. Derivation he is asking. And EX, EY, HX, HY. B1, D1, just now I said, na? Next, discuss about field patterns of TM mode in rectangular waveguide. Field patterns. So today we discussed completely about rectangular waveguide. Prepare this one for the examination. You will get compulsory one essay question. From short questions, which questions can be accepted? Short, parallel plane waveguide, or group velocity, phase velocity. Don't leave short questions. Parallel plane waveguide, or else phase velocity, group velocity. That will come as a short question.